In this presentation, we will focus on the transferability of the technology. That means the results obtained from the generation and dosage of coagulants in an industrial wastewater treatment plant, in particular, JOVIAR facilities. First, we will introduce the partners involved in this phase of the project. Then, we will cover the selection of scraps, metals, and brines, which are the main inputs in our technology. Then we will detail the generation of coagulants using the company brines, and we are going to cover the results obtained using our coagulants in the industrial plant. Finally, we will talk about the conclusions that we reached in this part of the project. As a brief introduction to AIDIMME, we are a research center focused in the metal and wood processing, as well as packaging and related industries. Our mission is to improve the metal, mechanical, and wood sectors in their products and processes. Our services include research and innovation projects, technological services, and laboratory analysis, as well as education through different masters and specialized courses. Our industrial partner in this phase is JOVIAR, a company based in Alicante, whose main activity is the manufacturing of technical pieces through thermal injection. They also produce molds and carry out electrolytic finishes. And JOVIAR has more than 60 years of experience in this field, which makes an excellent partner to validate this technology. As the overview of the context, we have three problems to solve. On the one hand, we have the brines, which we have a high generation of brines worldwide, coming mostly from desalination plants due to the scarcity of water. These brines are normally discharged without treatment, which has a negative environmental impact as they increase the salinity of the ecosystems. Then, for the metals, there is a global scarcity of raw materials, which combined to the political instability results in an increase of price of these metals. So it would be very interesting to recover as much as we can, including these scrap metals. And finally, the coagulants. There is a high consumption of coagulants worldwide, used both in urban and industrial wastewater treatment plants. They are normally outsourced and are subject to constant price increases, and both the prices and the demand are expected to increase because of the stringent requirements in the effluent concentrations. So our proposed solution is to valorize these two wastes and transform them into resources as new reagents of the water treatment plants. We do this in the project through electrolysis, which is the way to valorize these two wastes into coagulants. Let's look at the details of our process. Okay, as we mentioned, scrap metals and brines are the main inputs of the plant, but we cannot accept any type of waste. As any other project or process, we need to carefully assess the quality of the metals and brines that go inside the system. First, for the selection of metals, we have to evaluate the quality, it means their composition, to avoid water contamination, the inhibition of the biological treatment, and of course to ensure the good quality of the coagulants produced. We also have to make sure that the shape, the thickness, and the dimensions were compatible in our specific pilot, and of course the price and the availability of those metals. Even though they are scrap metals, they are not for free and they still have a cost. On the other hand, we have to identify the most suitable source of brines for our ELS system. And the brines can come from, for example, from desalination plants or purification systems, in particular from sectors that use high quality water in their processes. The characterization of brines is essential to make sure that they have no pollutants, such as heavy metals, that compromise the quality of the coagulants. We also checked, for example, the conductivity, which is a key parameter, as the power consumption is directly related to this parameter. The higher the conductivity, the lower the energy consumption of the process. Okay, JOVIAR requires pure water for their high quality processes, so they need to treat their water using a demineralization equipment as the one in this scheme, and which is the one in the picture. The characterization of the brines is essential, as you have known, and this equipment generates several waste streams during its cleaning cycles. That means that we cannot use them directly, but we have to prepare the optimum mixture. What we did is to choose and mix the different streams from the anionic and the cationic column to create an adequate mix for the input of the pilot system. In the end, we were able to use up to the 70% of the streams generated, which also represented a direct saving for the company in waste management costs. The values of the parameters that were measured were within the optimum range defined for the system. So the next step after getting these brines is the generation of coagulants. As you can see in the picture, we introduced the brines from the company in the ELS pilot, the mixtures that we prepared from the demineralization equipment. So we produced both iron and aluminum coagulants. The concentration achieved for iron was around 1,000 and 1,500 ppm, and for aluminum 800 and 1,000 ppm. As you can see in the picture, they have a very characteristic appearance depending on the metal used. This one is iron and this one is aluminum. So with the coagulants produced, we move on to the most important step of this phase, which is testing them in JOVIAR water treatment plant. That means replacing their conventional coagulants. First, what we did is to define the optimum dosage of the coagulant using jar tests, and then introduce these coagulants into the mixing tank of their plant. As you may know, the surface treatment sector treats waters with a high content in heavy metal, so our goal was to demonstrate that we could effectively remove them from the effluent water, that is, this part of the treatment plant. The results were very good, as we achieved the removal efficiency above 90% for all metals. That means zinc, copper, chromium, and nickel. Besides, the treated water met the EPSAR discharge limits, which means that this water was efficiently treated and can be safely released to the sewer. This validation shows that our coagulants perform at least as well as conventional alternatives in a real industrial setting. As the life cycle assessment, we also carried out an initial life cycle assessment to compare the environmental impact of our approach versus the conventional treatment using lime. As an overall comparison, the conventional treatment generates more than 1.4 kilos of carbon dioxide, while the aluminum and iron coagulants produced in the project generate 1.3 and 1.2 respectively, as it can be seen in the graph. If we look to the details in this study, we can see that the main cost of this difference is the production and transport of the conventional coagulant, as well as the sludge generation, which is higher for the conventional coagulants. So finally, to sum up, we performed the characterization of JOVIAR industrial brines and obtained suitable mixtures for the ELS treatment, allowing the valorization of 70% of the brines on site. We also demonstrated that the coagulants produced are safe and effective for the removal of heavy metals, so the water can be discharged in compliance with the EPSAR regulations. The life cycle assessment confirmed that our approach has a lower environmental impact compared to the conventional coagulants, and overall, this phase of the project has proven that our technology offers an efficient, scalable, and robust valorization of metal scraps and industrial brines, turning waste into resources. Thank you very much for your attention.
LIFE Waste2Coag has received funding from the LIFE program of the European Union.